Hi, I am Arib. You are watching my YouTube channel. Static relay. Static relay in electrical systems. A static relay is a type of relay, an electrically operated switch that has no moving parts. Static relays are contrasted with electromechanical relays, which use moving parts to create a switching action. Both types of relay control electrical circuit through a switch that is open or closed depending upon an electrical input. Static relays may be based on analog solid-state circuit, digital logic circuit, or microprocessor-based designs. Some authors use the term static relay to refer only to solid-state relays. Static relays have been designed to perform similar functions with the use of electronic circuit control as an electromechanical relay performs with the use of moving parts or electromechanical relay. The time delay for the switching action can be adjusted by adjusting the distance traveled by the disk, whereas in a static relay the delay can be set by adjusting the value of the resistance in an RC time delay circuit. Static relay working principle. The working of the static relay is, first, the current transformer potential transformer receives the input voltage current signal from the transmission line, gives it to the rectifier. After that, this rectifier changes the AC signal into DC, and this is given to the measuring unit of the relay. Static relay types. There are different types of static relays available which are discussed below: electronic relays, transductor relays, transistor relays, rectifier bridge relays, Gauss effect relays, electronic relay. Now, this measuring unit identifies the input signal level. After that it comparators the magnitude, the phase of the signal with the available comparator in the measuring unit. This comparator compares the IP signal to make sure whether the signal is defective or not. After that, this amplifier amplifies the signal's magnitude, transmits it to the OP device to activate the trip coil to trip the circuit breaker. An electronic relay is one kind of electronic switch used to operate the circuit contacts by opening-closing without any mechanical action. So, in this type of relay, the current carrier pilot relaying method is utilized to protect the transmission line. In this type of relay, electronic valves are mainly utilized as measuring units. Transductor relay. Transductor relay is also known as magnetic amplifier relay, which is very simple mechanically, even though some of them may be electrically little complicated, so this does not change their reliability, as their operation is mostly dependent on stationary components whose characteristics are simply predetermined verified. Thus they are very easy to design test as compared to electromechanical relays. The maintenance of these relays is negligible practically. Electronic relay. The electronic relay is a type of an electronic switch that opens or closes the circuit contacts by using electronic component without any mechanical operation. In this relay, the current carrier pilot relaying scheme is used for the protection of the transmission line. Transistor relay. A transistor relay is the most generally used static relay, where the transistor in this relay works like a triode to overcome the limitations caused by the electronic valves. In this relay, a transistor is used as an amplifying device, a switching device, which makes it suitable for attaining any functional characteristic. Generally, transistor circuits cannot perform only the necessary relay functions, but also provide the required flexibility. Applications. The applications of static relay include the following. These relays are widely used in very high-speed based protection systems of HVAC transmission lines with distance protection. These are also used in earth fault over currents protection systems. These are used in long-medium transmission protection. It is used to guard parallel feeders. It gives backup safety to the unit. These are used in interconnected T-connected lines. Thus, This is all about an overview of a static relay working with applications. These relays are also called solid-state switch, which is used to control the load by turning on-off once the exterior voltage supply is given across the device's input terminals. These relays are semiconductor devices that utilize solid-state semiconductor electrical properties such as MOSFET, transistors, and triac to perform input-output switching operations. Advantages and disadvantages. Advantages: these relays consume very less power. This relay gives very quick response, high reliability, accuracy, and long life. It is shockproof. It doesn't include any thermal storage troubles. This type of relay amplifies the IP signal, which enhances their sensitivity. The unwanted tripping chance is less. These relays have maximum resistance to shock, so they can operate easily in earthquake-prone regions. It needs less maintenance. It has a very quick response time. These types of relays give resistance to shock vibrations. It has a very quick resetting time. It operates for an extremely long period. It consumes very less power, draws power from a secondary DC supply. Disadvantages: the components used in this relay are extremely responsive to the electrostatic discharges, which mean unexpected electron flows between the charged objects. So, special maintenance is necessary to the components so that it does not affect the electrostatic discharges. This relay is affected easily by high voltage surges. So, precautions must be taken to avoid damage throughout voltage spikes. The relay working mainly depends on the used components in the circuit. This relay has less overloading capacity compared to the electromagnetic relay. This relay is extremely costly. This relay construction is simply affected by the surrounding interference. These are responsive to voltage transients. The semiconductors devices characteristics like diodes, transistors, etc. utilized in these relays change by temperature aging. The reliability of these relays mainly depends on a number of small components, their connections. These relays have less short-time overload capacity as compared to electromechanical relays. The operation of this relay can be simply affected because of the aging of the components. This relay operation speed is limited by the component's mechanical inertia. These are not applicable for commercial purposes.